It's that guy again. As if you didn't have enough of that. So today we talk about backwards incompatible tails. You know who that is already. So today I wanted to talk about wizards and stuff, and I read my abstract again, and I said, oh my god, what have I done? My abstract has, well, it has kind of to do with this, but effectively I should stop projecting my fantasies and whatever on magic and whatever in the open source world. I think it is more relevant to look at modern day magicians. This is Margaret Hamilton, and that is kind of like the code that either she wrote or she supervised to get us to crazy places. I think modern magicians have done much more than what you can see in fantasy tales. Effectively, thanks to this work, we got to the moon. We got stuff from generally science, engineering. We got science that gives us, cures for illnesses that are otherwise just invisible to us. We got stuff like Takeshi's Castle. I know that's not a great achievement. Okay, I still believe Takeshi's Castle is awesome. Okay, so we have this very nice environment in which engineering right now thrives. We are some of the best paid people on the planet for the job we do, because effectively we just sit and write code, and we use our brain. I'm not saying it's easy, but it's a very good time to be a software engineer. But not everything goes well. Anybody know what this is? This is a 737-800. It's a plane. It's been flying around for ages. The model is probably even older than me. And what happened recently to this is a few accidents. So what happened is that another company, Airbus, came in and said, oh, you can save this much money by buying our planes instead of the ones by Boeing, because we save fuel. So the business people from Boeing went a bit crazy and said, okay, we need to fight back. We need to improve our models, because how am I going to afford my next Ferrari otherwise? Okay. So it was a change in requirements. The idea is that the plane needs to consume less fuel, need to be more economical to fly. A few years pass, and ta-da! We got something new. This is the 737 MAX. It's the new iteration of this thing, and business went like, oh yeah, money, thanks, well done. And they sold a bunch of these. So in order to make this work, they had some system changes to do. And this talk is about changes. Okay, I'm pushing it to an extreme here because, by the way, don't take this too heavily. Okay, I realize people died. I don't want to make something about who is wrong, who's right. It's just about to prove a point that changes are risky. So what they had to do is they took the old model and they had this little engine and they put in a much larger engine. And in order to do that, they had to move the engine up. And what happens is that when the plane takes off and generally flies, if it peaks up too much and starts going up, it can stall. And stalling is basically when you get the heebie-jeebies because the plane is falling in mid-air, okay? So it is a design decision to do this, and they have changes to do to make it work. Aerodynamics, it's not easy. This is proper rocket science. When you talk about rocket science, these are the people doing rocket science, so they did their best, absolutely. But you got uncertainty about, is it going to work, is it not going to work? They found some problems. And then there was the business pressure, as in we just need to deliver, because otherwise we can't sell, and if we can't sell, we can't get the new Ferrari. They sold this new plane saying nothing changed. Absolutely nothing changed. It's good to go. Here's a 2-hour recap on all you need to know about this plane, and then you can go and take off. So what happened here is that in order to fix this idea that if the plane picks up too much, it's going to stall, they introduced a new system, a software system controlled by a sensor, one sensor, which was another mistake. Okay. And sometimes the system was not working correctly and it breaks. And since the change was not communicated, what happened is that effectively, oh, you can't see that. Great. Well, effectively, the plane went down, whereas it was thinking of flying straight. And this could have been avoided by just telling the pilot that there's a button to be pressed if this happens. That's it, all right? Looks like a simple thing. It's a problem in changes in requirements, and communication about these changes. Okay, shit happens. This is really, really bad, and it is an extreme, okay? Don't take it to heart. It's just to show that it can have disastrous consequences. So, we are talking about backwards compatibility. Backwards compatibility, short BC, is the idea that you have a new system designed and engineered, and it is supposed to work with the pre-existing system. That it is backward compatibility. It's like you buy a plug from the Apple store, right? You know it's not going to work with the next iPhone. Okay, so it's backward compatible. You know that basically they guarantee that you have to buy a new phone and a new plug and everything. That's how they make billions. Backward compatibility breaks are changes in the system that force you to adopt another system to make the new system work with yours. The first BC break was when we changed from BC to AD. That was a proper BC break. So this Brian of Nazareth guy 2,000 years ago or whatever. I'm not the Messiah. All right, so BC breaks are normal. You do change systems and they will happen. You just have to deal with it, you have to communicate it, and you have to recognize them. A lot of pull requests that I see for libraries that I maintain do not consider backward compatibility. And it's not because the author has bad intent, it's just because they don't know about all the things that can break. This is what the talk is about. You have changes in how the system works, in the assumptions behind it. These changes require a system change. So, as a baseline, everything you change is always a backward compatibility break, because any observable behavior of a system is the API of a system. It does not matter if you documented how your library works or how it doesn't. As long as people use it in a certain way, that's how it is. You change it, it breaks, that's it, okay? It's not up to you to kind of like say, oh yeah, but we never guaranteed that or this. You can make it explicit, in which case you're basically pushing the responsibility onto the consumer. But effectively, any change is already a BC break to some extent. The fact is that in the real world, the only constant is change. I mentioned it yesterday. This is something that the Greeks figured out ages ago. So you will always need to adapt software. Software is never done. Okay, the definition of done is bullshit. There is no definition of done. You have done for a feature, yeah, but next week something's going to happen anyway. Okay, so let's look at PHP. Specifically, we look at PHP object-oriented programming, short POOP. And we specifically want to look at changes in types as a first. So now I got a bit of a quiz time, just to see how far people figure out what is a BC break and what not. Any volunteer to keep account, right, of how many answers wrong we got? Well, I'm gonna get you, okay? Just keep account, that's all right. I just didn't figure out how to put a counter in the slides, because I'm lazy. So, a class is removed from a code base. Is that a BC break? Yes. Okay, fair enough. So far so good. This is easy stuff, all right? So, a class is made abstract. We have our hello world, we make it abstract. Is this a BC break? Yes. It is a BC break because we can no longer instantiate it or unserialize it. Don't unserialize other people's stuff. We have an interface and we make it a class. Is this a BC break? Okay, kind of. Depends. Is that class up to you to implement or not? Well, anyway. We have an abstract function. Sorry, a function is made abstract. You have a concrete function, now it is abstract. Is this a BC break? Yeah. So the idea is you now have to implement it in subclass. Okay. We have a class and we make it final. Is this a BC break? Yeah. So you see this is easy because in some way you're breaking it really loudly in a system for somebody else. We have a function and we make it final. Yeah, also BC break, fair enough. We have a public property and we remove it. Is this a BC break? Yeah, fair enough. You cannot access, you cannot write, you cannot read, and effectively code breaks. We have a protected property and we remove it, yeah? I would say it depends. And this depends on something that you would call the BC policy of a library. I think a BC policy is not really useful because you're basically saying, oh yeah, we realized too late that we have BC breaks, so we're going to introduce a policy. So now it's no longer our problem. So effectively, in a protected case, yes, it is a BC break. But some libraries say no, and they're wrong. We have a private property, and we remove a field. Is this a BC break? Depends. Is this object supposed to be serialized or not? If it is supposed to be serialized and the property is gone, you may have a serialization issue. You don't know about that, it depends. But again, serialization is part of a public API, so it's a bit hard to discuss that. You see, it's not so clear. It's not always black and white here. We have a public property, and we add the public property. Is this a BC break? No. Depends. Adding a public property breaks some weird stuff like looping over an object. You know that you can loop over objects in PHP? If you don't, now you know. And now I told you also to not do it, okay? Noted, don't loop over objects. It's a bad idea, don't do that. But effectively, it can affect that, it can affect array casting, it can affect JSON encoding, it can affect serialization again. Anything that has to do with state mutation is always a bit blurred. State is a mess to handle, best if not having it in first place, okay? So effectively, the end of the talk is don't write software, right? Because it's hard. You have an interface, and we add a method. Is this a BC break? Yeah. Effectively, you're breaking all the implementations. This is the same as the abstract method added. You have a class, and you add the public method on it. Is this a BC break? Ha, very good. It is a BC break, because effectively, this class is not final, right? So what happens is that somebody can subclass it. And if somebody subclasses it and makes a decorator, this is a hello decorator, which extends hello world and says something with a parent says something. You added a method that is unknown to the decorator now, and that decorator is now broken in a very, very hard to debug way, because it's a very subtle BC break. This one is going to be a bit more loud. So you have a child class with a private method with the same name. This is going to be a loud crash. Rare, can happen, really rare. It's best if you get a crash. But this one is super subtle. It can happen. It happened in Doctrine. In Doctrine, we added a repository count method. And anyone implementing repositories and extending from our repositories, we had something like 7 or 8 issues reported from people that said, my count is not equal your count, and now PHP is complaining. At least they got the warning. I don't want to know how many people have it without the warning. Okay? Okay, so we have a new class added to the code base. Is this a busy break? It depends. Is it in your namespace? Then I would say no, absolutely. But this is a discussion that often happens in PHP. Do we declare a new class with an RFC, and what is the risk of this class clashing with an existing definition in userland? This is why PSR 1 or 2 says, please put stuff in your namespace and not the global namespace. Don't do that. Don't declare functions and classes in the global namespace. It's a bad idea. Don't stop. Get help. Okay. We have a class and we remove an ancestor from the class. Is this a busy break? Yeah, definitely a busy break. Now, wherever hello world is used in the code base, type checks for the parent class will no longer pass. Also, it is unclear if hello provided more API. You don't know. Assuming that it didn't have any API, it is still a busy break. Because from a type perspective, your type changed completely. We'll see that in a moment about types. We add an ancestor. Is this a busy break? It depends. Did the ancestor add API? Then we have the same implications of public methods, state, and other things added. Arguably, otherwise, I would say no. And the reason is because there are scenarios where you say, is this thing an instance of blah? And now this particular condition passes. Very rare, but it changes behavior downstream. Really dangerous stuff. Hard to figure out that. So it depends. I'd rather say no, but still, scary stuff can happen. We have a property declared as a string, and we change it to a nullable string. I'm using 7.4 because you should already be using 7.4, by the way. I already do. So why can't you do that? We have Docker, right? You can compile from source. Well, don't. Is this a busy break? Yes. Okay, so it is a busy break because if I am reading from this property, now I can get a null value. I do the opposite. I have a nullable string, and I make it a string. Is this a busy break? Yeah. Writing to the string will now break, of course. So, grossly oversimplified example of mathematical concept that I'm not really supposed to explain. The idea is that you have two concepts that are called covariance and contravariance. A is covariant to B if all values of A are also values of B. This is what covariance means. So A is covariant to B if A is a smaller set of B, smaller or equal. Okay? Contravariance is the opposite concept. A is contravariant to B if all the values of B are also values of A. This applies to integers, numbers, potatoes, apples, functions, anything you can think of, and generic types. Types are really complex. So A is effectively contravariant to B if B is a subset of A. Now, when you have mutable state, since you have both possible operations of writing and reading, you have neither of those. You have to respect invariance. So you write and you read and you expect the exactly same set that you expected before. Because you cannot write things that are outside the set, so you cannot make it smaller. You cannot make the set larger, because otherwise when you read, you get broken state back, stuff that you did not expect. So more quiz time. Assuming, oh, this is stupid, I should have made the class final. Assume it final, okay? we have a class B which extends A, which means that B is a subset of A. So any B is an A, but not every A is a B. Okay? So we have an initial set that accepts A, and we change it to B. Is this a BC break? Yeah. The idea is effectively this is a BC break because now any consumer of this API may be passing as an instance of A that is not a B, and you have a crash. This is detected by static analysis. What happens with the opposite? We have, again, B is a subset of A. We have initially a restriction on B, and now we have a restriction on A on the parameter. Is this a BC break? No, because effectively we made the API more lax. It accepts more values. And by the way, if you do this and then you say, I changed my mind, you can't do that anymore. Software is hard. You did the mistake and that's it. The same for return types. So we have B extends A. Initially we return A and then we return B. Is this a BC break? No. Because B is a subset of A, now any consumer of this API will get something that looks exactly like an A, exactly like before. The opposite, is this a BC break? We have a smaller set initially and a larger set afterwards. Consumers of this API may get something they were not expecting. So they will most likely get something and then call method on this object and the method does not exist. That's kind of the idea. So there's a nice RFC, by the way, that allows us to change signatures in subclasses, covariant, return, and contravariant parameters. It's accepted. There's no implementation yet. I mean, there is an implementation, but it's contested. But effectively, it allows us to have child classes with wider parameter types and stricter return types. So that's good if you have an interface for something like a repository, and instead of returning object, you want to return something very specific. You can do that, because that very specific thing is still an object, if you work with objects. So in POOP, the idea is that we are always respecting these two principles of variance and the list of substitution principle. Variance is what I explained to you. It's about bigger and larger and smaller sets. And the second concept is the list of substitution principle, which is a set of rules that says that a child class should still behave like the parent class. If we talk about classes, it can be interfaces, it can be fruits, up to you to decide. In POOP, we work with inheritance. So when you look at backwards compatibility breaks, what you are looking at from a type perspective is to always allow larger sets of possible values to be given and always return smaller sets of possible values back. So you are not breaking expectations because the invariants from the consumer perspective are maintained. So effectively, it's about does type X fit into type Y, where type Y is the previous type. It needs to fit somehow. Right. What about dependencies? You have a dependency, and there's a major version bump. Right? You depend on Symfony something, or ZenFramer something, and ZenFramer makes a major dependency bump. And you bump the dependency. Is that a BC break? No? Yeah? Depends. It depends on whether you used inheritance from that library or not. So if you depend on that library in such a way that your symbols extend or inherit in some way from the symbols of the dependency, and that particular symbol, not all of the library, that particular symbol changed, then you have a BC break. Otherwise not. So it is tricky. My tip in this scenario is to not fight windmills. Don't try and go suicidal on it. Make things final. Stop inheriting from everything. If you can avoid inheritance, do avoid it, because inheritance is some of the strongest coupling you can have in a code base. And make things internal. So if you declare something and you say, this is just because I need it, and it's not supposed to be touched or seen by others, declare it internal. Internal does not prevent others from using it, but it puts a boundary between what is my problem and what is your problem. Okay? So it's just like, oh, you were speeding. Sorry, but that's your problem. The car was never designed to drive at that speed. We never actually tested it at that speed. It's regulations even say that you cannot go at that speed, so it's your problem now. That's the idea. This kind of check, this kind of category of checks, which are, I would say, simpler, can be automated, because all of this comes from the types that we can have declared in a very explicit way inside PHP. And I wrote a tool called backwards compatibility check, and you install it as a dependency or as a var. I think I deploy it as a var as well. I don't use the var, but. And you run it and you say, please check from 262 to master. And just to give an example of what it gives us back is it will say, look, doctrine or m blah, blah, blah was removed, and this particular method was removed. I mean, this invalid argument exception should have been marked internal. It wasn't. I have no guarantee that somebody else is not using it. Or here it says, new entity found through relationship change from an array to a non-counter variant, this other type. Okay, this means that in this case it changed completely. We got from an array to an object. But the idea is that it tries to apply these variance decisions to your code base. And then there's the hard part. I think this is the harder kind of BC break, which is changes in behavior. Changes in behavior are intentional. They are most likely by design. And they're harder to detect because, at least in PHP, the type system is not expressive enough to highlight that a decision is completely different. For example, right, the country of Germany decides that with green, you now stop, and with red, you go. It's still a semaphore, it looks the same, but now it's a completely different way of seeing it, looking at the problem. And good luck with anyone crossing the border, by the way. So this is a bit harder. You now need a human to check it. You need people to look at requirement changes. And you need to look at the running code instead of just the types. So it is more about the implementation. An example here is we added a check. The user, is it a web user? If it is a web user, then throw an exception. Okay? Otherwise, show the prices. This is, again, just somewhere in the wild, you added some code, and you have this added check. So anybody coming from the web cannot do that anymore. But maybe your API is also considered a web user, so now you broke your API. Maybe your system was designed to talk through different layers. Right? You added a check, and now you're breaking somebody's microservice somewhere that should not have been written in the first place. You have something like, if the price is negative, throw an exception. I had this in a production system last year, in which we figured out that we were actually issuing valid negative invoices between two companies. And they expected negative invoices because that's how they handle discounts between them. Instead of having one invoice with a discount in it, they made two invoices. One is negative. Perfectly valid, but we instead were fixing another bug where we tried to avoid negative prices. By the way, price is not an integer. Try not to code it that way. This is a mistake in first place. But you add a condition, everything falls apart. So far, this is easy to detect because you get new exceptions. You see these things in the logs. This is still easier than having some random thing happen. This stops the system. Here we have something more complex. You have a file selector, and you select, previously only files were selected, and now you select files and directory because you want to generate a zip file. And before, you would just put things in a directory and it would ignore those files. Now suddenly somebody puts a symlink into your directory and it downloads the world. And it generates a zip file of 20 gigabytes instead of 2 kilobytes. This could be fine, but it could also be a security issue. Now files that were not supposed to be in there are also in there. You don't know where this is going to be used. This could be a library very, very deep in your dependencies, and it changes how your system behaves in a massive way. Then there's subtle things. This is for tinkerers, people that rely on this sort of stuff. You have the sysop that is used to, hack together bash scripts, and they know that if the server produces this particular error message, it needs a restart. Okay? And now you change this and you added the quotes around it because of developer experience, and their system broke. I wouldn't categorize this as a BC break, but you see that systems are fragile, especially when the type declarations are not what is driving the systems, and when you're doing things with stringly typed systems, or integers, and stuff like that. Pricing, ordering. You want to sort prices by some weight, and you change the weight, and then your UI, which is assuming that everything is sorted, no longer behaves the way it was behaving before. Or you change the sorting from ascending to descending. I'm not sure what this can cause, and I'm pushing it. I'm just pushing it to make you think about what can break with all of this. So this kind of BC break is behavioral. And how do you detect this? How do you detect these kind of behavioral BC breaks? Anybody? Tests. Yes. So this is where the testing, besides the side where you design and make your system reliable, this is where tests are also providing a massive added value. Because whenever you see a test change that is not just a type change, you know that something in the behavior changed in your system. So if you don't have tests, and I saw somebody tweeting about 1975, right? Well, anyway, if you don't have tests, that is no longer acceptable. So it is how it is. You're not going to figure out if something breaks by just looking at the diffs. Yes, you can, but it's going to be hard. Whereas you look at a test change, and you see clearly that there is a problem. So in a repository, in an open source repository, you see a pull request, and somebody changes a test, you either question it or reject it. But you don't accept it right away, because a test change is very risky. Something is breaking in a way that is not necessarily how you intended the change to behave. So tests pay off massively on this. The other thing you can do is using a mature versioning system. So don't use romantic versioning or my mother's versioning or my uncle's versioning or whatever. Use semantic versioning. Semantic versioning has this typical X, Y, Z. Big X, which means arg, ouch. That's the idea. Is arg cool and easy? Cool is new stuff, and easy is, yeah, nobody cares. So effectively, you are going to have things broken, improved, and fixed. And a BC break that is evident and that you know of, so if you know there is a BC break, should only be in the X, nothing else. You know there's something that is going to break downstream consumers, it should be in there, and that's it. This is not always possible. A very, very big example of this is the language we use. The implementation of the language we use has BC breaks all the time. Functions that produce new warnings. Input-output operations that no longer behave the same. Flags that get changed. Hashing algorithms that get changed all the time. And this happens in minor versions. To the point where there's this legend among PHP developers that you should always skip the .0 version of PHP. No, if it is .0, it's stable. Use it. Otherwise, nobody is going to figure out if something broke, by the way. But this happens, and it happens also in patch releases. And this is because PHP is designed in a pre-composer, pre-dynamic libraries included at runtime era, where PHP basically includes a lot of libraries and a lot of API that can change based on dependencies, based on the operating system that you rely upon, because it's shared libraries, based on a security fix of some sort. And the other thing is that a BC break can also happen in a bug fix. There's this nice XKCD. So the idea here is, yeah, I fixed it in version 10.7. The CPU no longer overheats when you keep the spacebar. And somebody goes and says, yeah, but this breaks my workflow. I used to couple the control key to a high rise in CPU temperature. Okay, when the CPU goes high in temperature, I'm gonna be pressing control. So please add a flag to allow me to do whatever I was doing before. This is extreme, but it is effectively what is going to happen. Any observable effect of your system is going to be some sort of API. There is an exception to all of this, which is security releases. Security releases are potentially breaking things, and you still want them to be propagated to consumers, even if it's going to break them. And the reason is that a broken system is better than a compromised system. If it doesn't run, it's better than if it runs but under a government that is not your own. Okay? Yes. So, effectively, you break BC, and effectively, you are fixing a massive hole somewhere. Maybe somebody relies on it. Cool. They're going to have to work for fixing it. And all the others are going to be fixed, though. All the others are going to be safe. So somebody will have a system crash, and all the others are going to have a system not compromised. So breaking BC, in general, is more work for anybody that comes after you. The idea is that, therefore, you should make the BC break count. There must be a reason behind it, and the reason must outwin the amount of work that you are producing downstream. You can also do it because you like it. It's your weekend if you're doing open source. I realize that most open source developers are just doing it for shit and giggles. But you should make it count, because anything you do is going to break something downstream, and somebody is going to have a bad week after that. So be mindful of that. The other thing is announce it. The plain example is an extreme example. Extreme. But announce it. You can use the tooling that I wrote that makes a nice list, so you don't need to figure it all out up front. You just copy-paste the output of that, put it in the release notes. That's it. And anything that is a test change, you should document why you did it. So, other things you can do is deprecating things instead of, just throwing it out and saying, just hope that it works. You can also release alpha, beta, and release candidate versions so that people that have the time to mess with your dependencies actually put that time in to figure out whether something broke in a way that you did not foresee. So it's kind of like an exploration. How many things did we break? And we are not talking about bugs, we're still talking about BC breaks, not bugs. Bugs happen. There's nothing you can do about it. BC breaks happen too. It's just a very particular way of looking at a bug. Other things you should think about is don't release and go on vacation. There's this movement of, yeah, we deploy on Friday. Cool, awesome, you like working on Saturday. I realize you can make it as stable as possible and push it and push it and push it and have continuous releases anytime. You can do that, and you have the continuous delivery and whatever, but things break. And not necessarily always bugs. Also because somebody releases a feature that is super important, and then they realize that the specification was broken. We've done this so many things. I worked on a project for 2 years, and we developed a server-side application, and then the CTO came after 2 years, right? Large team of developers came over and said, you know what, it needs to be a mobile app. It can't be a server-side application. Well, thanks for telling us, right? Just 2 years. So it's not necessarily just about software. Things break at different levels. So if you release, you should have at least a bit of a window to look at it and say, yeah, looks all right. In deployment systems that are automated, this is called canary releases, maybe. But canary releases give you confidence about the technical failures, not the business level failures. So you can measure things like how much money are we making? Are we losing money after this release? Cool. And if you get the invoice at the end of the month only, that's probably too late to figure out that you were using a lot of AWS resources. You can also revert a BC break. I'm not really sure about this, but if you release it now and you figure out there's a BC break within the next 2 hours, I would not be 100% sure of it, but you can probably release a patch release with a BC break that is just about reverting the existing one. So you're changing the API back to what it was. It's risky, but it's going to be less damage than having a BC break that should never have slipped through. In order for that to work correctly and having this entire major release work, you should have education about how to use semantic versioning in Composer, and Composer is an amazing tool. Niels did an amazing job on this entire system of how to get things together in a dependency graph. You can have these regular these matchers on semantic versioning. So you do this tilde, ampersand, sorry, this is not quote, how's it called? Caret, oh thanks. So you select 1.2.3 and that means anything up to 2.0, but stop at 2.0. 2.0 is not our interest. So semantic versioning gives us these selectors and they're really powerful. So if you're doing a library, stop doing stuff like this. Don't ever do this. We used to do this at the beginning of the life of projects in Composer. Ages ago, we had these dependencies, even on PHP. So you have very, very old libraries with this kind of selector, and by mistake, somebody requires your library, and you get a very, very old version because that version had this selector. So we are still paying for mistakes that we did a decade ago for libraries that we released with something like this in the matchers. It still happens that somebody installs Zen Framework 2.0 instead of 2.7 whatever. Okay, it still happens. And don't use the star. This is the that star. The star, yeah, that star is coined, I think, by Sebastian Bergman. So you can automate BC breaks, BC break checks. Use the library because CI failures are better than annoying contributors. And I wrote the library because I have this reputation of telling people no. Sorry, but no, we can't do that. So effectively, it's kind of like a rolling gag, you know? Marco is going to reject it anyway. Okay, so CI failures over comments and annoying and closing stuff. The CI failure will tell your contributor immediately that something cannot be done. And it's simpler. So, to conclude, what do we say to the useless BC break? No, won't fix. All right, thank you very much.